Today's lesson is 4.5 scatter plots in lines of fit. Our objective today is to investigate relationships between quantities by using a scatter plot and a line of fit to make predictions. The algebra standard is 4.5. We have studied scatter plots before. Scatter plots are plotting of real-life data on a graph, and there are three possibilities. So if the data seems to have a general trend upward, like this, that would be a positive correlation. And you always read the graph from left to right, so you say as the x increases, the y increases. And when you're having to describe that, instead of saying x, you would say whatever the title is of the x-axis. So as the x increases, whatever it's titled, the y also increases. A negative correlation would mean that as the x increases, the y decreases because there's a general trend downhill from left to right. And then finally, if the data points are scattered all over the place, you can't see a trend uphill or downhill in any way, you would say that there's no correlation. So what we're going to do today is we're going to see and decide if there is a correlation to begin with. And if there is a correlation, you have to describe it. You say as the x-axis label increases, because you always read the x-axis from left to right and it's always increasing. You then have to say what happens with the y-axis, whether it would be increasing or decreasing. So our first example is the temperature outside and the heat bill. So that would mean the temperature outside would be at 0 here on the left, and it would be going up as you go outside. So we're talking something like 10 degrees, 20 degrees, all the way over to maybe 100 degrees. So our heat bill, if it's 0 degrees, our heat bill is going to be very high because it's cold outside. You're going to have to pay a lot to heat your house. And it's still going to be high when it's 10 degrees and 20 degrees and 30 degrees. But as it gets warmer outside, maybe 60, 70, you're not going to even have a heat bill. And it's going to come down. So I would think that your temperature outside with your heat bill would have a negative correlation. So you would answer that it has a negative correlation. So that'd be the first part of your answer. And then you need to describe it. So you're going to use, like I said, the labels on the x and y axis. So you would say, as temperature outside increases, the heat bill decreases. And that would make definitely a negative correlation, because as one is increasing and the other's decreasing, that is a negative correlation. All right, let's look at our next example. And this one would be time studying and your math test score. So as your time studying increases, so in this corner it's always 0. So increasing time might be in minutes, so 10 minutes, 20 minutes, all the way up to whatever a respectable amount of studying would be. But your time studying increases, what's going to happen to your math test score? So if you're studying not at all, some people can do well on math tests, but some cannot. So in general, no studying time would result in a lower test score. And as time studying increases, you would think that your test scores in general would go up. Now, that's not absolute with everybody. I know people could argue this, but in general, as time studying increases, your math test scores are going to increase. You have to think of the average population. So that would result in a positive correlation. And you must also describe it. So as time studying increases, math test scores increase. And that would result in a positive correlation. Okay, what we have done here so far, you've done in pre-algebra. Now we have to step it up and do what this really means for algebra. You would look at a scatter plot and you would pick out 2 points that would be the most descriptive of the scatter plot. In other words, it would help you make a line that would go in the general direction of the points, that would demonstrate the general trend, and you use those 2 points to write an equation just like we've done this week. So what you're going to do is you're going to pick 2 points that demonstrate the general trend, use those 2 points to write an equation, use the equation to make a prediction with future values. So we're going to look at example C. It says use the graph and line of fit to predict. So I've already got one plotted. How much it costs to talk on an international call. So on this graph, I have the number of minutes on the x-axis, and I've got the cost of the call on the y-axis. And I've already gone ahead and picked 2 points out. And when you make a line of fit, you want it to go through the points, generally have some above, some below, but have a general trend like the points. You want to pick points where you can definitely see what the points are. You don't want to have to guess where the points are. So in other words, you want points that actually hit on corners, like that one definitely hits 2, 4. And this one definitely hits 16, 16. That's why I picked those 2. You can tell the exact points where they are. If you're given a table with it, that makes it better, where you would know exactly what the points are. But on an I-STEP test, sometimes they give you the points already plotted, and you wouldn't know, so you want to pick the ones that are definitely on corners. So I'm going to use the scatter point and the data points 2, 4, and 16, 16 to write a line of fit and predict for 35 minutes what the cost would be of that call. So you have to start off with finding the slope. So I'm going to definitely do the slope formula. So I would use y2 minus y1 over x2 minus x1. So 12 over 14. My slope is 6/7. Use your slope-intercept form. Y equals 6/7 x plus b. Now I'm going to definitely pick the lower of the 2 points, which would be 2, 4, and plug them in. So 4 for y equals 6/7 times 2 plus b. I'm going to put 2 over 1. So 4 equals 12/7 plus b. And to solve this, I'm going to kill the fraction, maybe to help it make it a little easier. And to kill the fraction, I'm going to multiply both times, or everything times 7. 28 equals 12 plus 7b. Subtract 12. 16 equals 7b, and divide by 7. So my y-intercept is 16/7. So here's my equation. Y equals 6/7 x plus 16 over 7. Not very nice. It's very messy, but that happens with real life data. So this would be one of your answers, that you have the whole equation written in slope-intercept form. And now I need to make a prediction of what the cost would be for 35 minutes. And remember, on the graph, minutes were on your x-axis, so you plug that in for your x. Y equals 6/7 times 35 plus 16 over 7. Put 35 over 1. And 7 and 35 cancel to 1 and 5. So 30 plus 16/7. Okay, so I'm going to go ahead and say 30 plus, if I divide that out, I get 2.29. We're going to put this in money. So rounding off, it's going to be $32.29. And you might have to do that on these because we are talking real life situation, real life money. So $32.29 would be my prediction. Okay, so for the homework today, I am going to skip ahead here for you. You're going to do practice 4-5. So the first two, you're going to make a decision whether it's a positive correlation, negative correlation, or none. And you have to look at the general trend and see if there is a correlation. So as the x increases, does the y increase or decrease? And you have to describe the situation based on the x and y axis. Okay, you have to name it. I'm also going to help you out on these so that you know which points to use so that we're kind of all on the same page. For problem 3, I definitely want you to use 2001 and 2005. Okay, so go ahead and graph the scatter plot like it says in step A, and then draw the line of fit, but I'm telling you ahead of time which ones to pick, 2001, 2005, so that way the equation's the same for all of us. And for problem 4, I'm going to do kind of the same thing. You're going to draw the scatter plot, draw the line of fit. This one I want you to use the 1540 and the 3570 to draw your line of fit and to write the equation. You have to make the prediction based on that information. So these are the points that I want you to use. Okay, good luck.